Factoring trinomials when a is not equal to 1. To factor trinomials, we can use our grouping method. We're going to be splitting our middle term to create an equivalent polynomial where we have 4 terms so that we can factor by grouping. So our quadratic trinomials, a is our quadratic term coefficient, b is our linear term coefficient, and c is our constant. So we're going to start by finding 2 numbers that multiply to give us a times c and add to give us b. And when we find those 2 numbers, that's when we can split our middle term so that we can factor by grouping. So let's look at a couple of examples. So here we have 3x squared plus 13x plus 12. We notice there's not a GCF for these 3 terms. So that means we need to split our middle term, which is 13x, so that we can factor by grouping. So to split that middle term, we're going to start by doing a times c, which is 3 times 12, which gives us 36. So we're trying to find 2 numbers that multiply to give us 36, but add to give us b, and b here is 13. So we can go through our factor pairs of 36 and then check those sums. And we get to 4 times 9, which added together equals 13. So we're going to split this middle term to be 4x plus 9x. Just taking that 4 and that 9 and adding that x there. So now we have 3x squared plus 4x plus 9x plus 12. If you were to be given this and asked to simplify, you would combine like terms to get your original. So we know this is equivalent. And now let's factor by grouping. So we group our first 2 terms and our last 2 terms. Our GCF of those first 2 terms is just x. We're left with 3x plus 4. GCF of those last 2 terms, positive 3, and we're left with 3x plus 4. We see we have the same thing in parentheses, so we factored that out, and we're left with x plus 3. Oftentimes, when we're factoring trinomials like this, we're going to see GCFs such as x, such as 1. So don't be nervous if that is your GCF. Remember, factoring by grouping, we have to get the same thing in parentheses, bring it out, and then whatever our original GCFs were, drop those down. And that's our answer. To check it, we can double distribute our terms and then combine like terms to make sure it's our original problem. Okay, let's work one more. I encourage you to pause the video and give this problem a chance. Here we're factoring. We notice, looking at our 3 terms, we don't have a GCF, so that means we need to split the middle term and then factor by grouping. But we have to pick numbers that will allow us to factor by grouping. So we start by doing a times c, which is 3 times 4, which gives us 12. And then we're looking at what 2 numbers multiply to give us ac and add to give us b, which is a -8. Okay, so this one's going to be a little different. Whenever we go through our factor pairs here, if we look at the factor pair 1 times 12, when we add that together, that's a positive 13, right? We're never going to be adding 2 positive numbers to give us a negative. Maybe you're asking yourself, okay, well, we can make the larger number negative. That will give us a negative sum. But 1 times -12 is not a positive 12. Here, what we need to do is make both of our factors negative. A negative times a negative is a positive, and that allows us to get a negative sum. All right, so let's go through the negative factor pairs and check to see if they add to give us -8. All right, -2 times -6. All right, that adds to give us -8. So now we can split that middle term. We're going to drop down that 3x squared, and then we are going to take our numbers here. So we'll have -2x minus 6x plus 4. You could have also written -6x minus 2x. Your next step would look a little different, but you'll still get the same answer. I'll explain that again in a second. So now that we have split our middle term, let's factor by grouping. So we group our first two terms, our second two terms. The GCF of our first two terms is x. Factor that out, we're left with 3x minus 2. GCF of our second two terms is -2. Factor that out, we're left with 3x minus 2. We're excited. We see the same thing in parentheses, so we're able to factor that out, being left with x minus 2. If you had ordered these two differently, you would have gotten the answer x minus 2 times 3x minus 2. These two are the exact same because they're the same factors, just a different order, and we know the order of multiplication doesn't matter. Remember, to check our answer, we could use our distributive property. So that's how we can factor trinomials when our a value is not equal to 1. It also works when a equals 1, but that will be a special case in the next video.